Although speeding is rarely studied by economists, it has great economic relevance. In the United States alone, speeding is a factor in 30% of all fatal automobile crashes, with an economic cost to society of more than $40 billion per year. Law enforcement units around the world face the challenge of deterring drivers from committing this costly and potentially tragic crime. Barcelona GSE affiliated professor Jan Eckert has developed a model demonstrating the optimal use of random police crackdowns as a part of an effective deterrence strategy.
When I first learned about the announced speed controls, I was struck with disbelief. How on earth can it be possible that the police is going to be able to reduce speeding when they announce the controls? True, there will be less speeding during the announced controls, but when there's no announced controls, knowing that the police cannot be everywhere, people are going to speed more. So even the police themselves, I learned later, didn't really know exactly why it worked, but they had done some trial runs and they've learned that speeding was reduced when the announced controls were in place.
Crackdowns are intermittent periods of high-intensity policing. The date, time and location of the crackdown are publicized in advance. Police in several countries, such as Netherlands, Belgium, Germany and Australia, use random crackdowns to deter speeding. While criminologists use psychological theories to explain why random crackdowns deter people from committing a crime, Professor Eckert's model offers compelling rational evidence based on police and citizens' incentives.
To illustrate how it works, consider the following thought experiment. There's 100 drivers and the key thing is that they are different. Half of them never speed, they have no propensity to speed, but the other half of them have a really strong propensity to speed. In fact, they would only be deterred from speeding if they know they're going to be caught for sure. Now suppose that the police has resources to monitor 50 out of the 100 total drivers. Then what they would do is, in random monitoring, a normal monitoring event, they would actually have half of probability, 50-50, for a high propensity speeder to be monitored. Now what does that mean? The high propensity speeder is going to speed because he's not deterred. Instead, suppose there's two roads, A and B, and on road A we're going to monitor everyone, and suppose half of the drivers are low propensity, half of the drivers are high propensity. Now we have 25 speeders there, high propensity speeders, that are going to be monitored for sure. If they are monitored for sure, that means that they are going to stop speeding. So there's a reduction in the number of speeders of 25 drivers. And this is really what the real effect is. The reduction is bigger during the announced controls than on average.
Professor Eckert demonstrated the use of the crackdown model by applying it to traffic data from the Belgian province of Eastern Flanders between the years of 2000 and 2003. Together with his colleagues Nicola Persico and Petra Todd, he observed all radar controls in that time period, both announced and unannounced.
We are interested to know whether an increase in the deterrence, for example the number of tickets that can be issued, is going to have an effect on speeding behavior. We can look at the people's propensity to speed, but also at weather conditions, the road conditions, the type of cars that are on the road. And we find indeed that the speeding behavior is reduced under crackdown, and in fact we find that the marginal benefit of the additional monitoring effort is equal to the marginal cost, which indicates that the police is optimally allocating the resources.
The Belgian example shows that there is a rational economic argument for employing random crackdowns as part of a policing strategy. Analyzing law enforcement tactics from an economic standpoint provides a compelling counterpoint to the subjective risk assessments made by criminologists.
We can verify whether our model is consistent with the data, for example by looking at the effect of an increase in the resources. And we find that the rational explanation that we propose is consistent with the data over the more psychological explanations. And this is not so surprising. You might think that people are not behaving fully rational, but we are talking here about drivers who are mostly commuters, so they take on a typical year the same road probably between 300 to 500 times a year. And so they have a very good idea of what the probability is of being monitored.
Professor Eckert's theory of optimal random crackdowns can be applied to a variety of situations in which perceived police controls give citizens the incentive not to engage in criminal activity. Other examples are sobriety checkpoints to catch drunk drivers, or raids on suspected drug traffickers in particular neighborhoods.
Having a methodology for estimating the deterrence of speeding and for therefore optimally allocating police resources is important, because ultimately what we care about is not just the reduction in speeding but the reduction in accident, and that's the true cost to society.